Hi everyone, welcome to this little supplementary lesson on combustion reactions, specifically for those of hydrocarbons. We're going to cover one that seemed to have caused some confusion on the last exam, and one for this most recent worksheet, just to help understand how to balance a combustion reaction. And the principles are just the same as when it came to synthesis, decomposition, single displacement substitution, or double displacement metathesis reactions. We're just trying to balance the number of atoms on each side of our reaction. Well, in this one from our exam, C4H10 plus molecular oxygen yielding carbon dioxide and water. Usually for combustion reactions, it's best to try to balance carbon first and to balance oxygen last. But for this one, we can kind of cheat if we just realize one thing. Whatever coefficients we have on the reactant side, we are always going to have some multiple of 4 for carbon, some multiple of 10 for hydrogen, and some multiple of 2 for the number of oxygen. That means, specifically, we are always going to have an even number of each of those elements. So that gives us a clue that on the product side, we're going to need some even number so that we have an even number of carbon eventually. But more importantly, we are also going to need some even number in front of H2O, because if we have an odd coefficient, that will end up giving us an odd number of oxygen, which we won't be able to balance on the reactant side. So just because for this particular problem, it's best to it'll be easiest for us if we try to get a number of oxygen that's even. Well, let's say we try to balance the number of hydrogen. There's 10 hydrogen represented on the reactant side, and hydrogen only shows up on the product side as part of water. So to balance that, we could put a coefficient of 5 in front of H2O. However, that would give us an odd number of oxygen. So instead of putting a coefficient of 5 in front of H2O, let's put the next coefficient that lets us have a multiple of 10. Well, the next multiple would be a coefficient of 10, actually. Because if we put 6 times 2 would be 12. If we put 7 times 2 hydrogen would be 14. We wouldn't be able to put something on the reactant side to balance with that. But if we just have a coefficient of 10, waters, well, 10 times 2 gives us 20 total hydrogen. And currently, 10 times 1 oxygen is 10, plus 2 on the CO2 is 12. We're going to save oxygen for last when we balance it for combustion reactions, usually no matter what. But what's important now is no matter what, we have an even number of oxygen, because anything we put in front of CO2 will still give us an even number of oxygen. So we're not going to balance oxygen until last. We just affected the total number of hydrogen. Let's try to balance that now. Going to the reactant side, since there's less atoms of hydrogen represented, we want to get that up to 20. So let's put a coefficient of 2 in front of the molecule C2 or C4H10. Well, that causes us to have 2 times 4 carbon, or a total number of 8. And that causes us to have 2 times 10 hydrogen, or a total number of 20. The number of hydrogen atoms are now balanced, so let's now go and balance carbon since we just changed that number. Well, we want a total number of 8 carbon. We do not have that on the product side, but that's easy. We can just put a coefficient of 8 in front of CO2. So now we have 8 times 1, or 8 carbons. And as far as oxygen, we have 8 times 2 from CO2. That gives us 16, plus 10 times 1 oxygen and water. 16 plus 10 would be 26. Now then, our carbon is balanced, our hydrogen is balanced, and we have an even number of oxygen on our product side. Therefore, we can just put some number that when multiplied by 2 gives us 26, or we can just put in 13. And that gives us a total number of 26 oxygen atoms. So to balance this reaction, it needs to be 2, 13, 8, and 10. Now then, that was just using a trick through some critical thinking of trying to make sure we have an even number of oxygen and balancing hydrogen such that we had a multiple 10 on the product side and going from there. But let's say we just did the normal way where we just assume, let's save hydrogen and oxygen for last and instead just balance carbon first. Well, for atoms of carbon represented on the reactant side, we could add a coefficient of 4 in front of CO2. That would cause us to have 4 carbon represented. As far as the number of oxygen, 4 times 2, 8, plus the 1 from water would be 9, and that's cool. Next thing we would need to do is balance hydrogen, which we have 10 on the reactant side. Let's make sure we have 10 on the product side. And we can do that by instead having 5 times 2, or 10 hydrogen, and then we would have 4 times 2 plus 5 times 1, or 8 plus 5, or 13 oxygen atoms. Now, the problem here is, just like before, we didn't use our little trick to quickly get to this realization, but we have an odd number of oxygen on the product side. We can't go to the reactants and simply multiply something by 2 to get an odd number. So what this tells us is we need to change the number in front of H2O again in order to get an even number of oxygen. Now, to save us time, no matter what number we put in front of H2O, it needs to be something that when multiplied by 2 gives us a multiple 10, because that's something we can balance on the reactant side. So therefore, we eventually get back to the same scenario where we have to change this number to 10 so that we have a total number of 20 hydrogen atoms on that side. And now we have 18 oxygen. And we're going to try to balance hydrogen. So we're going to put now a 2 in front of C4H10 because that gets us 20 hydrogen. And now we're going to do the general rule of once we balance one element, balance the next one that we just affected. We balanced hydrogen, we just affected the number of carbon, because now we have 2 times 4, or 8 atoms of carbon. Let's try to balance that one now. What I think might have been a trick is some people may feel that once they put a number, a coefficient in front of something, they have to keep it. That's not true. So we now have 8 atoms of carbon on our reactant side. We only have 4 represented on our product side. So let's instead change that 4 now to an 8. So now we have 8 atoms of carbon. And now we have 8 times 2 oxygen, 16, plus 10 times 1, 10, or 26. And that once again brings us back to the realization that we have a balanced number of carbon and hydrogen, and to balance the higher atoms numbers of oxygen on the product side, we're going to need to have a coefficient of 13 on our reactant side. So what I think might have happened is people tried to balance carbon first, putting a 4 there, and then be rigid in not being willing to change that number if they needed to later. Now let's go into the worksheet one. We have ethanol, C2H5O6, plus molecular oxygen yields carbon dioxide gas, and water. This one, it's like the general trick of just leave hydrogen and oxygen for last. Let's just balance the number of carbon. There are 2 carbon atoms represented in ethanol, the reactant. Well, The only time we see carbon on the product side is part of CO2. Let's put a coefficient of 2 in front of CO2. So now that gives us 2 carbons. And as far as oxygen, that gives us 2 times 2 or 4 plus the 1 from water. Now following the general rule, let's save oxygen for last. We just balanced carbon, so the next thing is balanced number of hydrogen. There is more represented with ethanol on the reactant side because C2H5OH, that is 6 hydrogen. So let's balance those 6 hydrogen on the product side, which is easy. We only see hydrogen as part of water. Therefore, any number times 2 that equals 6 is going to need to be 3. So now we have 3 times 2 hydrogen, or 6. As far as the total number of oxygen, we have 2 times 2, or 4, plus 3 times 1, 3. 4 plus 3 is 7. Now, hydrogen and carbon are balanced, and we're in this odd situation where we have an odd number of oxygen. However, that's awesome. That is wonderful, because we have 1 oxygen represented in ethanol, the reactant ethanol, which means 7 minus 1 would be 6. So that means that we can get 6 hydrogen, the remaining 6, by placing a 3 coefficient in front of O2, so that we have 1 oxygen atom from ethanol and 3 times 2, or 6 oxygen atoms from molecular oxygen. So 6 plus 1 yields 7. So to balance this one, it would be 1, 3, 2, 3. And then one last little way of looking at this. This is just one more way that I've seen people try to solve this just by their understanding. They look at that odd number of oxygen on the reactant side and they try to make it automatically even, which not necessary to do, but let's see what happens if we do try to do that. Well, let's say we put a 2 in front of C2H5OH just so that no matter what, we now have an even number of oxygen on the reactant side. So placing a 2 there, that gives us 4 total carbon, 10 total hydrogen, and, well, currently 4 oxygen on the reactant side. Balancing carbon, we can put a coefficient of 4 for CO2, and that changes the number of oxygen to 8 plus 1, or 9. And if we go one step down and balance hydrogen, we currently have, that should be 12, my apologies. So we currently have 12 hydrogen represented on the reactant side. Well, then to get 12 on the product side, we just put a 6 in front of H2O. So now that is 12 hydrogen, and total number of oxygen of 4 times 2, 8, 6 times 1, 6. That would be 8 plus 6, or 14. Therefore, on the reactant side, if we want to get up to a total number of 14 oxygen, we already have 2, because we have 2 molecules of ethanol. So 14 minus 2 is 12. 6 times 2 would be would balance the number of oxygen to 14. Now, the issue here is that our coefficients, they all have some number that we can divide each one by. And when it comes to balancing a chemical equation, if you can divide all these coefficients by some number, divide it by that number. So in this case, we have 2, 6, 4, and 6. We would instead just divide each number by 2 because they're all even. Therefore, 2 divided by 2 would be 1, 6 divided by 2 would be 3, and 4 divided by 2 would be 2, and 6 divided by 2 would be 3, which would get us to 2 carbons on both sides of our chemical equation, 6 hydrogen on both sides, and then again 7 oxygen. Now this method was just for the rare situations where some people, they try to make sure that they always have an even number of oxygen, and for those who have not seen if you have all your coefficients as some number that can be divided by some number, whether they can all be divided by 2, 3, 4, whatever, and forgetting to divide them out to get the simplest terms, I'd say the best method is what we just did beforehand, which was just balance carbon, then balance hydrogen, then balance oxygen. That's what works for the worksheet. And in the prior example, just be willing to, if you are able to, make those quick connections of whether or not it's ever possible to have an odd number of oxygen on both sides, or if you need to make sure that they're even, and then see how you can probe that further. In any case, that would be our little supplement for combustion reactions. Hope that all goes well for all of you, and peace.